So myself, Shekhar Mehta from Vinshek. Vinshek basically is a value-added distributor of custom install audio, video, and control products in India. And today, one of the topic which we are going to cover today is basics of audio. So first slide talks about what is sound. So this is very important today. We have been spread across a lot of products and sound energy all across the place. So it is definitely important for us to understand what is sound. So sound is simply a type of energy vibrating through a medium such as air or water. So wherever there is sound which get mixed with the air molecules or water molecules, it creates an energy, a vibration, and that is known as sound. This energy within a specific range is termed as frequencies. So this has been very much designed in the form of frequencies interpreted as sound by the human ears. So sound is made up of three basic elements: frequency, intensity, and timbre. Frequency means how fast the vibrations are occurring. Intensity is how the loud sound is. And timbre is basically the sound quality. So going to the next slide, we'll be doing a touch base on all the three elements of sound: frequency, intensity, and timbre quality. The human ear can detect sound frequencies ranging from 20 to 20,000 hertz, or we can also say it as 20 to 20 kilohertz. However, the human ear is more sensitive to certain discrete low intensity frequencies ranging between 2000 to 5000 hertz. So from the imaginary images, what we can see, there are different cycles of wave of the frequency. So the frequency which are having more distance between the two cycles are recorded with a frequency of 3 hertz, and frequency which are more closer are noted as 8 hertz. So typically a human ear can listen between 20 hertz to 20 kilohertz. So we understood the frequency of sound when it comes to our human ears. So various frequencies will be having different cycles, and we will able to listen different sound performance. So the intensity is correspond to the amount of energy associated with that sound. What I mean to say is, when the frequencies which is having more cycles will have more intensity. So it has been measured in the form of decibels, used for measuring sound energy in a way that is relevant to how humans perceive loudness. You can definitely term intensity means the loudness of the sound. So loudness occurs with the variations of frequency in the same sound. So if we have more faster frequencies, the perceived loudness of that particular sound is either higher if, or it will be lower depending upon the frequency cycles. So this is a chart which talks about the various noise levels or the decibels of sound levels of different energies of sounds created by a lot of different environments. So leaves rustling, soft music, average home noise, normal conversation background music will be varied with a decibel of something like 30 to 60. I'll give an example here. So a standard projector, what we use in the office environments, usually create a decibel level of around 35 to 40 dB sound. So that sound is of either a bulb which is of 2000 watt, or whether it will be also the fan noise which is created inside the projector. So every product which is functioning will have its specific sound. Whether it is a bulb in the ceiling will also generate certain frequencies. A moving car will also create certain frequencies, a certain frequency of sound. So over here we can see this chart specifically. 80 to 89 dB is basically a frequency which are mainly been created by heavy traffic, window air conditioners, environment of a restaurant. So which is standard, which we can definitely able to take care. However, it has been usually termed that sound above 85 dB are harmful. So of course, we all human beings become uncomfortable when we are sitting in a noisy environment of restaurant. We often complain that the noise level is not good, or the acoustic level of that environment is not good. So it has been universally termed that 85 dB above, anything sound above 85 dB is harmful for human ears. However, there are a lot of other frequencies we definitely routinely we listen to it, whether it is basically uh, dance performance, or whether it is your rock concert, or any of these kind of events will definitely create a sound more than 100 dB, and we do listens to it for long duration of time. But anything which is heard up to a certain long hours can definitely impact our human ears. Obviously, when we talk about train horns, gunshots, specific siren, so they usually create 140 dB decibel level, which of course, if you hear for a long duration of time, it is definitely can damage your eardrums. Moving down to the next slide. So timbre, the third basic element of sound is timbre. So timbre basically defines the quality of sound. So first we understood the sound creates frequencies. Second, if the more frequencies are there in a specific sound, it will create an intensity. Intensity is termed as loudness. But timbre is basically the quality of sound. So timbre is a complex wave pattern. Of course, when there is a one sound of one particular product, which I have given an example over here, a tuning fork, when you start playing tuning fork, it will create only one frequency at that time. So it is usually termed as one fundamental frequency, because there is no other noise besides that tuning fork noise. However, if there are more noise besides a fundamental frequency, or rather we can term it as a single frequency, it's a complex wave pattern. So over there, quality is definitely hampered. So I like to give an example, like if there is one frequency, it will generate some specific hertz over there. But if the same frequency is been clubbed along with some other sound, so there are two different sound energies getting mixed up, and of course it affects the timbre quality. What I'm trying to explain here is, specifically when if you are speaking to somebody and somebody else is also joining you during that conversation, of course there are two or three people talking on the same subject, so there are different multiple fundamental frequencies, there are more fundamental frequencies over there. So at that time the timbre quality takes a very important role. So this is a precise reason when we talk about the quality of sound coming out of a lot of speakers or amplifiers, the manufacturer has to go through a lot of technology science behind to manufacture a product, so that whenever the sound energy is translated to amplifier or to speakers, it should give you a good quality sound wave patterns and gives you best quality of output or timbre quality of output from the speaker. So just to give an example, like this tunic fork is basically creating specifically the same sound. However, because of the different sizes, there would be a different hertz. Hertz means the different cycles in frequencies in all the three of them. So different frequencies cycles will be noted by using this all three different types of tunic forks. But basically the sound fundamental frequencies will be remaining same in all the three of them. And of course the timbre quality will also affect, because various frequency cycles are different in all the three tuning forks. So on the right hand side I have given a small video which shows the tuning fork. So on the video you saw, it's very beautiful small clip where I was trying to show that specifically when the tuning fork is getting played on the air, you will able to listen a different frequency cycle of sound. You can listen to different sound, but when the same tuning fork goes inside the water, it converts that water into a form of a sound waves in a different form, like of a sprinkle of water. So sound energies can give you different frequency wavelengths either on air molecules or whether it is water molecules, which will definitely defines the quality of sound. So we just understood what is the sound. Now we will just touch based upon microphones, and later on definitely we will be understanding more into the speakers, amplifiers and other topics. But to understand those segment, understanding microphone is very important. So what is microphone? So microphone is responsible for converting changes in sound pressure to changes in electrical current. So what I'm trying to say here is, when we speak, there are certain vibration which comes out of our mouth, and this vibration actually taken by the microphone, and that sound energy or sound pressure is converted into an electrical current. We will be understanding this philosophy on the next slide in a much better way. Of course, the intensity of the changes in sound pressure corresponds to amplitude, the AC voltage generated by the microphone. Let me give an example. that whenever you basically bring your microphone near to your face while you are speaking, the intensity of the sound increases, and same way the vocals what you're hearing from the speakers, you can feel that difference. So the intensity of the microphone will vary depending upon how close the microphone you bring nearer. The sound energy captured by the microphone will be high, and if you bring the microphone more nearer to you, the intensity of the output will be again different. Obviously, the overtones, the other sound in the environments are present. Those are also captured by the same microphone, and those will be also be converted into electrical signals. So energy which has been present in that area will be captured by the microphone. There are three types of microphones: dynamic, condenser, and electret. So these are majorly three types having three different functions, and these are majorly available in the current market. So first of all, we'll be doing a touch based on dynamic microphones. Okay, so I would like to make understanding more using the graphical image over here. So when the sound pressure, when we speak near to the microphone, is basically getting absorbed inside the microphone, and this microphone converts that sound energy, sound waves, into electrical current. So how this happens? It's very simple. Microphone usually have diaphragm in the front. So when you see on the right hand side of the image, there is a diaphragm. So this diaphragm is basically either made of paper or it is either made of plastic materials. So with this, we have a connected copper voice coil. So what happens here is this voice coil is also connected to the magnet. So when sound waves, when you speak near to the microphone, there is an vibration in the air, and that vibration sound waves are getting inside the diaphragm of the microphone, and that gives a signals to the voice coil, and with an air energy which is created inside are getting converted through the use of magnet to an electrical current, and that electrical signals are getting converted into your physical connection, either in RCA connector or phono connector or something like that. So of course, dynamic microphone works with this principle. So when varying sound pressure is applied to the diaphragm, whenever you speak on the dynamic microphone, it takes the signals from diaphragm. With the help of a magnet, the energy is created. It's get converted to an audio signals to a physical connector at the end. So, but it is very important to understand dynamic microphone fundamental, that these microphones are very rugged and they can work with a varied temperature range, environmental temperature range, and provide smooth and extended frequency response, because there is no electronic circuitry used inside this dynamic microphones, so they are as pure as what you speak or what this microphone can take from the environment. And most important, it works without an external power source. You don't require any power to create an energy inside this microphone. So dynamic microphones takes your signals with the air sound waves which comes to it, converts that signals to an electrical current. So that is dynamic microphone. So dynamic microphones are usually looks like this. So many people use this microphones for with the use of for like especially the vocalist or the singers prefers to use dynamic microphones because they are as natural as it could be. There is no alteration using some electronic circuitry inside this. So of course with the time this dynamic microphones have improved to a great extent to give you best voice intangibility. Better quality of diaphragms have been used so that the sound waves which is coming inside are translated in a much better way and gives you best performance. We go to the second type of microphone now, the condenser microphone. So the condenser microphone works with the help of a power. So if you see my slide, it uses a pair of charge plates that can brought closer together and forced farther apart by changes in air pressure. Again, I would like to give an example here. This particular condenser microphone is been powered by some battery inside. So when you see on the diaphragm side, this diaphragm is been connected with an electrical circuit here, and we have a basically charge plate below the diaphragm, which is also known as back panel, which is also connected with one of the wire to the battery. So what happens is this becomes, with the help of a battery, this becomes a sound sensitive capacitor. It gives the power to the microphone to catch the sound signals in a more effective way. It also gives you the possibility of picking up the sound energy waves from a distance. If the presenter is speaking around 12 inches away from the microphone also, this particular microphone, condenser microphone, will able to catch the sound even though the presenter or the vocalist is slightly far off from the microphone. Why? Because this particular battery helps the air energy to get trapped inside this specifically diaphragm, and it get remain for few seconds over there, for milliseconds over there, and it gives more power as a back panel to pick up the sound even though they are far off distance from the microphone. So this type of microphones works in conjunction to low noise, definitely because the pickup pattern has become more sensitive now. So it can take a lot of low noises in the environment. And also if there are certain noises which are present by the amplifiers from the speakers, it can also pick up that sound also, because they are more sensitive and they can pick up sound much better than the dynamic microphones. So condenser microphones are also known for providing crisp, low noise sound quality, and they are often used for producing high quality sound recordings also. So these are the type of microphones which I'm sure many people have seen around. So the first microphones what you saw on the top are the microphones like which are usually termed as gooseneck microphones, which are used on the podiums. So this condenser microphones allows presenter to stand 12 inches 17 inches away also, and this microphone will pick up the sound in a best quality and gives output to your amplifier or mixer, whatever it is. Of course, the new generation of wireless microphones are also termed as condenser microphones, because the wireless handheld microphone are also works with the principle of a battery inside it. When we talk about certain prominent studio recordings and everything, they also use condenser microphones for the best sound tangible quality. We move to the third slide, the electric microphone. So electric microphone is very unique. So is actually a combination of a standard microphone, like a dynamic microphone, and they usually used JFET IC inside a single package. What I'm trying to explain here is that a microphone will be a combination of a specific standard dynamic microphone, and they include some electronics inside this, which is often known as JFET ICs. So with the help of this electronic IC, basically the pickup pattern of this particular product of this electric microphones are much sound sensitive than condenser microphones. So usually in the old days, these electric microphones used to be in a big size, but with the time passed by, these electric microphones became more popular, and it started getting deployed in a lot of electronic devices. So why electric microphones in today's situation becomes more popular? Because because of the GFET ICs, which can be very small in size, the microphone development become much acceptable. So you can create smallest microphone using the electric microphone and can used in various other applications. So of course electric microphones has been evolved since many years now. So I'll just show the example of electric microphone used nowadays. So they have been used in laptops, mobile phones, and in a lot of small applications where you want to fit in microphones to small electronic devices. So that is possible because of a combination of dynamic and GFIT ICs, and this gives you a lot of possibilities of having deploying microphones in a lot of electronic market. So besides the three types of microphones, dynamic, condenser, and electric, of course there were a lot of microphone pickup patterns is also one of the subject to be understood, because you have to use different microphones for different applications. So this slide talks about different types of microphone pickup patterns. There are certain microphones designed with the form of omnidirectional patterns, which are perfect for interviews, moving subjects, cardioid patterns, so hypercardioid patterns, supercardioid, lobar unidirectional patterns, and bidirectional patterns. These are the 6 types of microphone pickup patterns used for various different applications, which I have mentioned in one smaller liner, that these are usually used in such areas. But I would like to show with a beautiful graphic what are the different pickup patterns here. So the first, omnidirectional pattern. So when you see on the right hand side, the omnidirectional pattern is basically will pick up sound from everywhere which is present in the environment. So of course, omnidirectional patterns many times are definitely very risky, and if you don't understand the different pickup patterns of microphones, you eventually go wrong many times in your projects if you have not taken a right type of microphone. So omnidirectional pattern usually is been picking up sound from all 360 degree from your environment which is present in the room. So of course, there are a lot of applications where these microphones are being used, where you have a group of people taking an interview, or there are certain areas where you want, like filmmakers use omnidirectional microphones to pick up the sound of an environment into an area, or anything of different applications to talk about. Going down to the second slide, the cardiac pattern. So cardiac pattern is basically it picks up pattern mainly for a lot of different applications. So they are mainly directive to a certain extent. So most of the cardiac pattern microphones will definitely highlights in their specification. The pickup pattern of this microphone will be like 45-degree, or it will be something like 55, 60-degree. So these microphones are being usually used for different applications, like doing some recordings, weddings, and a lot of different applications. So when you go to the next, hypercardioid, so you can see the diagrammatic image here. So this hypercardioid is again basically narrow, and it can pick up the sound pattern, the sound waves logically on a narrow form. So these are being used basically by a lot of people who wants to do a point based recording of some specific like a interviewer, or specifically to some certain specific subject they want to record to, specific to that sound only, ignoring the other region sound. Then hypercardioid sounds are being used. However, not to get confused, because hypercardioids many times have been wrongly confused with supercardioid microphones. So supercardioid microphones and hypercardioids both are different. So hypercardioid is definitely a narrow beam recording microphones, but supercardioid are more narrow, and it has been used for a lot of specific applications. Especially we have seen they have been used mostly by filmmakers, because this is like a point shot microphone recording, where you want the recording of some specific actor doing or talking about something specific, and you want sound of that particular person only. However, supercardioids are definitely very tricky, because you might have seen that there are certain specific filmmaking situations when there is a person who is taking a boom with a microphone on the top of it, and it has been targeted towards the actor, so that whatever the actor says, that particular microphone sound is being picked up by this supercardioid shotgun pattern microphones. So fifth one is unidirectional pattern. So this is again very popular microphone, mostly like as compared to the omnidirectional. Unidirectional is also very much in demand by a lot of different applications. So it is also known as lobar pattern. So lobar pattern is most directional pickup pattern you can use. Filmmakers love to use a lobar microphones, but it is difficult to manage it, because it is definitely more unidirectional than the cardioid patterns, but specifically it has very narrow beam of recording. So many times you have to be very sure while using this type of microphones. The sixth one is bidirectional pattern. So bidirectional microphone is having basically a pickup pattern from the front and even at the back side. So that is why the graphical image shows the pickup of both the sides, front and back, both the sides. So it is very important that you're using this microphone where you don't want a sound to be picked up from both the sides. So you can't use this microphone. So only specific applications these microphones have been used, especially like interviewing between two participants. So it pick up the sound from the front with some specific coverage area, and at the back side also it takes a specific coverage area of both the participants. So these were the 6 type of microphone pickup patterns which are available in the market, and people use it as per their own applications. So now the next topic we are talking about is speakers, which is definitely interesting for all of us. So we all love speakers, whether it is a party or a formal office presentation. Speakers have been placed for best presentation applications for good sound in those areas. Speakers have changed the way we listen to everybody all across the world. So what are the speakers? So speaker is a composition of driver. So image what you see here is a driver. So this have a lot of different components inside this speaker. So we on the right hand side I have shown the different components. We have specifically diaphragm, we have voice coil, we have magnets, we have dust cap. So if you see, speakers have the same components like dynamic microphones. Even dynamic microphone used to have the same diaphragm, magnets, voice coils. In the same fashion, speaker have the almost everything except few more addition of components like spider, surrounds, and the respective frame to handle the sound energy inside. Microphone converts sound signals into electrical signals, but speaker do absolutely opposite to that. It converts electrical signals into sound signals. So when you see an image over here, you can see the moving parts of the speaker. So when the signal, electrical signals, which are coming from a speaker wire to this speaker driver, it goes inside the voice coil. With the help of magnet, this voice coil moves up and down. The sound pressure energy is created inside, and with the help of a spider, the air, the vibration inside the driver pushes the diaphragm of the speaker in and out, and that air transfer energy is converted into sound signals. So of course I have mentioned that when a varying electrical signals is passed, varying means the variation in electrical signals passed through the voice coil. In bracket I have written movable voice coil. This is a movable voice coil. It moves up and down surrounded by a magnet. The coil moves back and forth. The coil moves back and forth. Cones. So cones is basically the materials. So whatever what you see here, the diaphragm specifically, often made of paper or a lot of different materials used nowadays in manufacturing speakers. That we will touch based on the few other next slides. But cones attached to the moving coil then produce variation in the air pressure, which is also known as sound waves, that generate sounds. So it is very similar to the dynamic microphone. In the same fashion, these speakers creates the sound from electrical current to the sound wave. So now we will let's like to understand how this speaker frequency, intensity, and timbre quality affects here to a speaker. Frequency, how fast the vibrations are occurring, spider and coil movement. So how fast this spider and coil moves back and forth. If it moves more fast, the frequency of the sound cycles are much higher. When the volume of the speaker is less, the frequency response cycle is slow. So in the same way, when the frequency is more higher, the intensity, what the loudness you listen from the speaker, you will feel it more powerful when the frequency cycles are more. If the frequency cycles are less, the intensity of the speaker will be definitely less perceived. So in both the things, it is important that how good the speaker is sounding. The speaker sounding is mainly dependent upon the manufacturer. To have the best quality of sound quality, the timbre quality of speaker, the manufacturer uses various types of materials inside the speakers, starting from magnets, good quality magnets, best quality of voice coils, and various material used on the driver qualities. Either you can say cones or drivers. So various manufacturer uses different types of materials to ensure the best quality of sound performance to sound performance. We move to the next slide, the types of speaker drivers. So frequency response and important speaker characteristics represent the frequency range over which a speaker can successfully propagate sound waves. Speaker drivers can be categorized according to the frequency range that they are designed for. So whenever we see a speaker driver, whether it is specifically designed for handling different frequency range. So woofer drivers are designed to produce low frequency less than 200 hertz. There are specific drivers which are designed to handle frequency range between 500 hertz to 3000 hertz. There are certain drivers which are designed to handle high frequency band, anything above 3000 hertz up to 20 kilohertz. And of course, there are certain drivers which are designed to handle the entire band of sound frequencies from 100 hertz to 15 kilohertz. So here I would like to point something important, that many times people often get confused with full range speakers and the new types of full range speakers consisting woofer, mid range and tutor. So there are specific range of full range drivers which produce all the three frequencies using single driver. So let me just go back to the slide where which I showed you an image over there. So this particular driver is a full range driver which eventually take care of all the three frequencies singly handled by this entire single cone, which is often known as full range driver. However, when we talk about new modern drivers are being used to generate different sound characteristics. So there are often multiple speakers in the market which will consist of either woofer drivers, mid-range drivers and tweeter drivers also, which is often known as two-way speakers and three-way speakers. So full range speakers have inferior sound qualities when compared to a sound system consisting of woofer, mid-range speakers and tweeters, because a separate drivers for handling three different type of frequencies will be any day will be better than a standard full range speaker, because individually the single drivers are taking care of frequency response which has been designed for each driver. So tutor will able to handle the high pass filters, the mid range will able to handle the mid signals of your frequency, and the woofer will able to handle the lowest frequency band, which is anything less than 100 hertz. So if you see the speaker on the right side, it's an example of a single speaker having 3 drivers in one cabinet. So they have a tutor driver, a woofer driver, and a mid-range driver. So this speaker will be any day will be performing better than the single driver producing a full range frequencies. So of course, nowadays these speakers are often termed as full range drivers by many people. So in today's modern world, when we talk about full range drivers, people often says that it's a 3 drivers combination single speaker. So when we see one particular image right now, this particular model is a 3-way speaker. So we have a tutor in the here, we have mid-range, and we have woofer. And of course, when we talk about manufacturing this speaker, we understood that the manufacturer use different types of materials to ensure best sound performance or best quality of sound. So manufacturers use either paper cones, or they will use polypropylene materials, which is nothing but it's like a kind of plastic composite polypropylene material, or many people used different types of materials to ensure better performance and better output from the same speaker. So this particular speaker is a 2-way speaker. It has one tutor and it has one large size woofer at the bottom. So of course, these both speakers are oftenly like used in the different applications. So there is always a query by a lot of end clients, which speakers are good, 2-way speakers are good or 3-way speakers are good. Undoubtedly the 3-way speakers will be sounding better because you have a separate driver for the mid range, which will able to generate mid frequencies, and it will give you a full band of frequencies from a single speaker. When we talk about 2-way speakers, they are able to handle high frequencies and low frequencies, but it also able to handle mid frequencies also. How that is possible? So manufacturers design some crossover boards, a PCB board at the backside of the speaker, and they basically design the crossover PCB boards to convert the full frequencies which is coming inside the speakers, and that mid frequency and low frequency is being translated to this woofer driver. So in most of the situation, these speakers, 2-way speakers, are mainly preferred, and it able to handle the full frequency band using the PCB crossover boards. But yes, if customer has the budget, and specifically people who want something best quality performance from their speakers, then we should target to use 3-way speakers. Then these are the various types of speakers. Again, when we see on this speaker is also a 3-way speaker. You have a tutor in the middle, mid range, and here we have 2 woofer drivers, and we have two woofer drivers. So and I'll jump down to the next photo. So this is also a three-way speaker, tutor, mid-range, and one, two, three, four woofers. So this particular speaker will able to give you better dynamics and more power as compared to this speaker. So the lower frequency generation on this particular speaker will be much higher as compared to speakers with two woofer drivers. Often many times people do ask me whether a specific 8-inch driver speaker will be more powerful than speaker having small size woofers of 5 inches, two numbers. So now this is definitely very subjective, but I can explain it with an example. If a user wants to listen to music as a stereo, and he wants to have a complete full frequencies of low band, then I would definitely recommend to go for 8 inches driver or anything bigger than that, because that particular speaker will able to give you good quality of subwoofer performance as compared to two small subwoofers. If we are targeting some specific cinema applications, we usually prefer to go for speakers. The moderate size rooms, we usually try to prefer to go for speakers which are smaller subwoofer drivers. Why? Because any cinema application, the low frequencies are often handled by a separate subwoofers. So if you take a speakers which are with a smaller size subwoofers for the cinema application, it is absolutely correct. There is no issue in that, because all lower frequencies are handled by a separate subwoofer in that room. So we understood basically the drivers, types of drivers while manufacturing a speaker, and its different frequency, quality, intensity, and wattage. But it is also important to understand how speaker works. So every speaker is manufactured with a nominal resistive load. Now, what is this load? So whenever amplification is fed into these two terminals, positive and negative terminals, it has its some resistive load for driving this speaker to its optimum performance. Of course, whether we say nominance, resistive load, or impedance, it is one and the same thing. So impedance is basically a technical term representing the impedance of the speaker. So when we see specifically this speaker, every speaker manufacturer usually highlight what impedance this speaker is manufactured with. So many manufacturers use different speaker with different impedance. So there are certain drivers which will mention 4 ohms. There are certain drivers which will mention 6 ohms, and there are certain drivers which will mention 8 ohms. So this speaker, what we are looking at is actually with 8 ohms. So different manufacturers often use different impedance because they have their own readings and calculations, and they feel that specific impedance are best for their speaker performance. So in today's situation, most of the speaker manufacturer started manufacturing speakers which are of with an impedance curve of 8 ohms. Why? Because they want that their speakers should be more universally accepted by most of the amplifiers available in the world. So as a commercial point of view, every speaker manufacturer wants that their speakers should be more accepted and installed at a lot of different applications and should take care of all the amplifiers which are available in the world. And that is a specific reason all the amplifier manufacturers have eventually started making amplifiers mainly streamlined to 8 ohms impedance curves. So I'll give you an example of understanding this phenomenon in a right way. There is a classroom where you have a teacher and a children's. So let's take an example as if like teacher is an amplifier and children's are basically speakers. When specific teacher is trying to explain a topic to all the children's, everybody is listening, but every children will have different way of understanding the same topic. They have different capability of understanding the same subject or same topic which is which are explained by the teacher. The same is the case when the amplifier is feeding power to the different types of speakers. They will have different impedance curves. So there are certain manufacturers who manufacture speaker drivers with 8 ohms. There are certain manufacturers who manufacture drivers with 4 ohms. And of course, we have seen certain speaker manufacturer who still manufacture products with 16 ohms drivers. So this examples gives a very much clear indication that specific impedance or the children's in the classes will able to have different understanding of the subject. If teacher try to basically make it more explaining to their children's, the every children many times not able to understand the subject correctly. So same as the things goes, if you are doing any mismatch in terms of connecting amplifier and speaker, there would be issue either at the amplifier side or issue at the speaker side. So as the demand increases for the different speakers, same thing goes with the different amplifiers. People started wanting more speakers to be connected for larger areas, for banquet halls, churches, temples, classrooms, auditoriums, etc. The only way to extend the speaker signals to long distance was possible by using LMT, the line matching transformer. This situation gave us development of volts based amplifiers and volts based speakers in the market. So this is how the transformer looks like, and this transformers were started getting deployed in a lot of speakers by default. So there are a lot of plenty of brands available in the market, whether we talk about Bosch, JBL, and a lot of prominent manufacturers started using these transformer based speakers for a lot of large requirements where you want multiple speakers to be connected. So this transformers converts your electrical current into the low impedance signals. I have a specific image which is good for understanding this. So there are transformer based 70 volt 100 volt amplifier which gives signals on 70 volt or 100 volt to the speaker, but it's an electrical current. You can't fit this electrical current to the standard speaker because every speaker is manufactured with impedance, which I have explained to you on my earlier slides. So they are low impedance signals. If you put this speaker cable into any speaker directly, it will blow away your speakers because these are electrical currents. So when the electrical signals are transferred from transformer based amplifier through a speaker cable, you need a transformer in between which converts that 70 volt signals to the low impedance. Of course, the transformers have been designed for handling different types of impedance of speakers. If your speaker is of 8 ohms, you need a transformer which will convert 70 volt signals or electrical signals into 8 ohms. If your speaker has been manufactured with 4 ohms, this transformer will convert 70 volt to 8 ohms. So why 70 volt signals are being used? Because an electrical signals can be multiplied to the larger numbers of speakers because there is no deterioration over there, and you can take it to a longer distance without any deterioration of sound signals over there. So with a distance of 50 to 80 meters or more than that, your speaker cable will able to take the electrical signals to each speaker or at the first speaker of the entire chain, and you can loop the first speaker 70 volt output to the second speaker, from second to third and third to multiple numbers of speakers. So the job of transformer is to convert that 70 volt signals into 8 ohms. An entire speakers which are there in the entire single speaker cable chain will able to play good sound which is powered by this amplifier. So we are end with the topic of speakers. We'll be now talking about the amplifiers. So what is amplifier? An electronic device which is used to amplitude the electrical signals is often known as amplifier. So signals which have been fed into your electronic device which can increase the signals, or you can say amplitude the electrical signals in a more loudness, is known as an amplifier. So a device consisting of an amplifier combined with a loudspeaker and used to increase the volume of the sound produced by electrical guitars and other musical instrument and source. So there are usually multiple types of amplifiers, but to make it more easy for a lot of people, I have classified this into two segments, so that these are the two market segment where majorly these kind of amplifiers are being used. And with the evolved of amplifications, lot of new things were being integrated into the standard amplifier. So we branch it out into the two segments: public addressing amplifiers, which are often usually works on 70 volts and 100 volts. So this particular amplifier has a transformer inside which converts your basically source signals into a 70 volt and 100 volt electrical current and gives you a speaker terminal at the backside, for which I have already explained to you in my previous slide how the electrical current is been transferred to the speaker, which has LMT built inside that. The second category is been segmented into the low impedance based stereo amplifiers. So they often works with an impedance 8 ohms, 4 ohms or 2 ohms impedance curves, and which is often used for mostly for the residential application because it has some specific advantages as compared to 70 volt amplifiers. So to understand this public addressing amplifiers, what is this? It is a combination of a standard amplifier which has a transformer of volt output, but with due course of time, people wanted to give lot of different inputs to this amplifier because these amplifiers have been used in lot of applications, commercial applications, where people wanted more inputs to be connected into this amplifier. But usually it used to have only one input. But with due course of time, with lot of demand in the market, people started using analog audio mixers. They used to feed in all the signals inside this mixer, take and master out from this and feed into this amplifier, which is definitely prevailing even today also for the larger scale of projects. However, there are specific small commercial projects where people don't want to use this analog audio mixers. So a new breed of amplifiers started coming in the market, which is a combination of these two, which is an amplifier and along with this analog audio mixer, which is often termed as today as a very routine term as a public addressing amplifier. So when you see this amplifier, there are a lot of multiple inputs on the front panel. So these are basically the microphone inputs. So you can connect 1, 2, 3, 4, 5 microphone input to this amplifier, as well as you can also connect multiple line inputs. Line inputs means the source inputs from your mobile phones, laptops, and a lot of other sources, CD player, etc., to the backside of this amplifier. So this particular amplifier mix the output of microphone and the line input and gives you the complete one single out from the speaker cable terminal, and you can connect to your either one speaker or to the multiple speakers connected on a one single chain using the speaker cable. So I have explained this on a small diagram based. You can connect laptop, you can connect wireless microphones, you can connect wired microphones to this, and this intake you can connect it to all of your speakers using one single wire speaker cable. Of course, this speaker wire cable is transferring the signals to the 70 volt protocol, and each speaker is having a transformer at the backside which is converting that 70 volt into normal impedance for the speaker. However, it is important to understand that because of the mixer amplifier, this is a mixer amplifier which is a combination of amplifier and an analog mixer. It gives you mix output to all the speakers. It will mix output means it will mix your microphone and laptop sound all into one and give you a master out to all of these speakers. Of course, you can vary the sound levels of your microphone differently. You can vary the sound level of your laptop separately. So laptop intensity microphone will be lower, and if you want microphone output to be higher, you can tweak it from the front panel of this microphone to achieve your desired results for your environment. So now we talk about the low impedance based amplifiers. So low impedance based amplifiers are unique. They performs much better than 70 volt amplifiers. So the question is why they perform better than 70 volt amplifier. The low impedance based amplifiers does no deterioration in sound because there are no transformer, line matching transformer used at the output side, because all the signals which has been fed into this amplifier is purely generated and given an out with left and right channel, so that you can connect two speakers to this amplifier and gives you best bandwidth of your full frequencies. So usually impedance based amplifier will able to handle high, mid and lows in a very efficient manner as compared to low voltage amplifiers, because low voltage amplifier are usually getting converted with an electrical current, and when you convert your line source signals into electrical current, when it converts the speaker when it converts the electrical signals at the speaker side using the LMT, the low frequencies are often get neglected over there. The transformer will not be able to handle the lower frequencies which is generated by the amplifier, because LMT is being used between the speaker. So even in the same amplifier, you can connect laptops, microphones, wireless microphones, not the wired microphones, because wired microphones are typically are will able to give you mic output. It will not give you a line output. But wireless microphones are often designed to give you line outputs from their receiver units. So those line inputs can be fed into this impedance amplifier also. But the catch here is, because they are impedance based amplifier, you can only connect either two speakers of 8 ohms on their left channel 1 and right channel 1 speaker. However, there is always a demand by a lot of system integrators and people who are doing the audio installation that we want more speakers to be connected to this amplifier because it generates good sound, and we don't want to use volt based amplifiers. So in such cases, there are certain amplifier manufacturers who often mentions in their specification sheet that my amplifier will able to handle up to 2 ohms or up to 4 ohms, so that you can actually load the amplifier by connecting more speakers to it, and the amplifier will able to handle the different ohm loads. So in my next image, I have shown you again a graphic example. So when there is an standard 8 ohms based amplifier, if the manufacturer mentioned that my amplifier will work on 8 ohms only, so you should always connect standard 8 ohms two speaker only, one on the left channel, one on the right channel. You should not never basically connect more speaker to it. If you do that, up to a certain application, for background music application, it will do the job. But if that the same user in one fine day, if he is doing some party, then what happens is the amplifier is not able to handle that load and will have a lot of issues later on after a certain duration of time. So if the amplifier mentions that my amplifier can handle 8 ohms and can handle up to 4 ohms also, then you can connect two speakers on each channel. Left channel you can connect two speakers. Of course, each speaker is of 8 ohms. And when you connect right channel also, two speakers. So you just have to see your amplifier datasheet should mention 8 ohms, 4 ohms. If it mentions that, then yes, you can connect two 8 ohm speakers to that. Uh, of course, I just want to highlight here that right now, whatever the speakers I am showcasing here, each speaker is of 8 ohms. If you are using different ohm speakers, like 4 ohm speakers, if you are using 4 ohms one speaker plus 4 ohms one speaker, the impedance to this amplifier will go to 2 ohms, and this amplifier will not able to handle 2 ohms. So that is again not the right way of connecting, and your speaker or other your amplifier after certain duration of time will get conked off. So it is important, it is very easy to just see the data sheet where your amplifier is able to handle up to 4 ohms. If it says up to 4 ohms, you can connect any 8 ohm speakers to two numbers on each channel. I didn't mention it here, but if your amplifier specifically talks about 8 ohms, 4 ohms, and he also mentions 2 ohms, 2 ohms also, then you can connect 3 speakers in one channel of this amplifier. On the left channel 3 speakers, on the right channel also 3 speakers, so that the entire load which goes to the amplifier while powering up these three speakers will go up to 2 ohms. But your amplifier should mention 2 ohms capability to handle multiple speakers. So in all the 3 slides, I have been highlighting one point here, that these impedance based amplifier usually will only able to select one single source and will be able to give output to the speaker cable only one single source output. They can't give mix output until unless it is specifically designed by certain manufacturers. Then you can mix sound of your various microphones and low impedance based source signals. That's a separate story. But usually the most of the amplifiers available on the low impedance based, they will never able to play back all the sources, and it will not mix it, and it will not give a complete output to your speaker channels. In this slide, I'm also mentioning that it is definitely not recommended to connect three speakers into low impedance based amplifier, even though if the manufacturer highlights that it is 2 ohms capable. You should not do that, because every amplifier, whether it is volt based amplifier or whether it is a 8 ohms based amplifier, they all have harmonic distortion levels. Harmonic distortion levels means if you pump up the volume to a desired level of 40 watt, 50 watt, or more than that, if you reach to 100% of your amplification, it will give some distortion in sound if you try to reach it at a higher volumes. Many times you often have experienced, when you pump up the volume of your amplifier, it gives you a lot of not clean sound from your speakers, and people often say that your speakers are not sounding good, they are giving some crackling sound or burst sound, as if speaker is not good. But the case is different here. Speakers always are good, but if the amplification is not rightly matched, it will give you a lot of such noises. And often customer such demo or the final installation at the client side will eventually gives a negative result of the amplifier and the speakers both. So I always recommend that even though amplifier mentioned up to 2 ohms, you should always try to connect maximum two speakers into one channel, so that it able to maintain good quality of sound when user is increasing the volume for his certain applications. क्या हुआ इसको? Okay guys, so besides the two types of amplifiers, now of course there are a lot of classes of amplifiers which manufacturers uses while manufacturing amplifiers. So there are various types of classes. Certain manufacturers use class A, certain uses class B, certain uses class AB, vacuum tube amplifiers class C, class D, and E, F, and GH. So of course, these classes are basically used by various amplifier manufacturers. The most two popular classes are class AB and class D. So class D amplifiers are usually more popular nowadays because they are highly efficient in terms of power usage. They gives you very less noise. The harmonic distortion level is on amplifiers are very least in this category. And very important, they are very small in sizes, because a standard amplifiers which are which we see usually by a lot of different manufacturers available in India, to name a few like Yamaha, Marantz, Denon, and all those amplifiers. Few of the models are actually class AB amplifiers, like stereo amplifiers. So yes, they certain few companies of the same these companies have started working on class D amplifiers also, because class D amplifiers are very compact in size. They are much more efficient and able to give you more channels, more speaker outputs, even though they are smaller in size than the standard class A B amplifiers. For example, like if you're using a standard one 2U is basically like a 3.75 inches rack based amplifier, will able to accommodate 2 channels, 4 channels. But if you want to go for specific more channels and more power in the amplifier with half the size of this class AB amplifiers, manufacturer has to opt for class D amplification only, so that they can make the amplifier compact in size, just 1U, which is 1.75 inches in height, and basically you can get more channels of amplification and more power to it. So this is just a link which I have shared at the bottom, which is a beautiful representation of all of these amplifiers, and they have tried to explain the different what are the different classes of amplifiers used and what difference it makes while opting for these different classes. So there's nothing like class C, class E, or class D are good. So every manufacturer has their own choices and own theory and own principles to design an amplifier, and they eventually manufacture products depending upon their own markets. So this is the end of the slide for the entire amplifier section now, and of course this is the last slide of my presentation. So I hope it was specifically good in understanding the various type of microphones, types of speakers, the categories of components used inside the speakers, and various type of amplifiers. So Vinshek will be now also be taking few more webinars very soon, and these particular webinars will be more on Vinshek product line, product orientation. So there are 2 webinars which I'll be taking again, which is more on Sonance and also on cornered audio. So Sonance is basically a US based, the leaders in architectural audio, and cornered is basically wall based, ceiling based speakers designed and manufactured in Denmark. So I'll be taking this on next week. So all of your participants are requested, if you find time and interesting in these 2 categories of brand, you are most happy to get sign up on this webinars, and we will take it up ahead.